It'll be momentum. Can anybody tell me what's the first thing that comes to mind when they hear that word? Because I know you've heard momentum before. You could write it in the chat, you can shout it out. Should I call on someone? Okay, so few people said movement. So I do like movement is definitely involved in momentum. All right. Um, Usually when I think of momentum, outside of a science context, I always think I always think of it as like some sort of forward motion, some sort of like in sports they talk about it as if you have like a certain amount of luck and you're moving forward with that luck almost kind of. All right, but um, for physics, for momentum, what it is, you guys, um, it's a very specific thing. Okay, and the easiest way to describe it is that momentum is inertia in motion. So everybody who said movement, like you were on the right track. You were right there. So inertia once again, I'm sorry, momentum once again is inertia in motion. So in order to have momentum, you have to be moving. Okay? Now, there's a picture of this truck on this slide. So we had a question on the last test. I think it was on the last test yesterday, and it asked like which has more momentum, a truck that's sitting still or a truck that's moving at 50 miles per hour. I'm sorry. I'm sorry, you guys. I'm messing up. It said which has more inertia, a truck that's sitting still or a truck that's moving at 50 miles per hour. So which one of those has more inertia? The sitting truck at rest at a red light, or the one going down the highway at 50?
The one going down the highway.
So that's a really good thought. But do you guys remember what is inertia? Like what was
Man.
it's mass, right? So if a truck is sitting still and a truck is moving, does its mass change in those two situations?
Oh, I thought we were talking about momentum.
No,
No,
I'm
no,
sorry.
no.
It's because I confused you. That's why. Because it was because of how I asked the question. But on yesterday's test, when we talked about inertia, you guys, um, the truck that's sitting still, the truck that's moving at 50, they have the same inertia, right? Because inertia is mass. But in this example, for momentum, they will not have the same momentum, right? And the truck that's moving fast is going to have more momentum. The truck that's stopped will have zero momentum because you have to be moving to have momentum. All right. Now, how how are we going to mathematically define what momentum is? Well, let's think about what I just said on the last slide. All right. We first are going to have to know the amount of inertia that's in the object. And we just said we measure the amount of inertia by measuring the what? You can type it in, you can shout it out.
Isn't it mass?
It is mass, right? So the mass of an object is the amount of inertia that it has. Okay, so we know that in our mathematical definition of momentum, we're going to have mass in there. Now, what quantity do we have that describes an object's motion? Um, and it has the direction that an object is moving, it has the speed it's moving. So, what quantity do we have that describes the motion of an object? Nobody knows this one? So if I asked you how fast you were moving and what direction you were moving in, what is that? I'll give you guys a hint. We learned it in the first unit. It is velocity. Thank you. So the velocity describes the motion of the object. So right here we have the mass is the inertia. The velocity describes the motion. So our mathematical definition is going to have those two things in it. Okay, so how do we mathematically define momentum? Well, momentum, you guys, is going to be the mass of an object times the velocity. That is the equation for momentum. Momentum is equal to mass times velocity. So that's the first new equation of this unit. We won't have too many equations in this unit, but this is the main one right here. Momentum is mass times velocity. Now, you guys know that we abbreviate mass as m, and we abbreviate velocity as v. So I can't use m for momentum, right? M is already taken. So when we write the equation out in short form, P stands for momentum. So P equals mv. That means momentum equals mass times velocity. So I would take a moment and write this equation with all of your other equations. So now let's talk units. What are the units for mass? Giovanni, I'll call on you. Giovanni, do you know what the unit for mass is in physics? Okay, I'm not sure he's here. Maricruz, what's the unit for mass?
Typed it in chat.
I'm sorry, what?
He typed the answer in chat.
Oh, I see it now. Thank you. Okay, so mass is kilograms. Okay, Maricruz, what's the unit for velocity? Yep, meters per second. Okay, so velocity is going to be meters per second. So if mass is kilograms and velocity is meters per second, what that means is the units for momentum are going to be kilograms meters per second. So that is the unit for velocity. Now there's no shorthand version of that. Some other units that we'll be talking about, or that we already have talked about, like I'll give you an example. When we did force was mass times acceleration. So remember the units for force were kilograms meters per second squared. But we never used this. We always called force a Newton, right? So we always used a capital N to abbreviate force. There's nothing like that for momentum. So momentum is just going to be a kilogram meter per second. So mass, kilograms, velocity, meters per second, momentum, kilogram meters per second. All right, so let's do a sample problem. Oh, actually, before we talk about a sample problem, let's actually talk about the relationships between the variables first. So if I keep momentum of an object constant, let's write this down. So let's say I have P equals mv, all right? So if I have a constant momentum, that means the relationship between mass and velocity, it has to be inversely proportional. So for everyone who's going to take the SAT, either again or they have to do it. Still, remember that an inversely proportional relationship, if I were to graph it, it would look like this. So if with a constant momentum, if the mass is big, the velocity would have to be small. And if the mass was small, the velocity would have to be big. So if I had, say, a baseball and I had a shot put, and we've been talking a lot about shot puts. Remember, they're those big, heavy balls that the track people throw. Okay, so the shot put is significantly heavier than the baseball. If they were going to have the same momentum, the velocity of the baseball would have to be much bigger than the velocity of the shot put. All right, so if the mass was little here, the velocity would have to be really big. If the mass is big here, the velocity has to be little. That's what our graph is showing us. So the other thing, the other relationship is, let's say that I have momentum equals mass times velocity. Let's say that I'm keeping the mass constant. So I'm looking at the relationship between momentum and velocity here. If I have, say, a car, right? It's my car, and I'm going on a street in Northlake. So the speed limit in Northlake is 30 miles per hour. My velocity is 30. Now I drive down to 290 where I can go 55 miles per hour, so almost double the speed. If I double my velocity, what happens to the momentum of my car? So it will increase. If I double the velocity, the momentum increases, and actually if I double the velocity, the momentum doubles. If I triple the velocity, the momentum triples. So remember, if I were to graph momentum and velocity, right, the graph would look like this. So as long as I keep the mass constant, if the velocity goes up, momentum goes up. And that's a linear relationship, so it's a straight line. Now, let's say that I kept the velocity constant, but I was changing the mass. So instead of throwing a shot put, I threw a baseball, but I threw the two of them at the same speed. Okay? So if a shot put is going at the same speed as a baseball, the shot put is a lot heavier, which will have more momentum. The shot put going, say, 10 meters per second, or the baseball going 10 meters per second. So I want everyone to type an answer, whether you're right or wrong. Just everyone, it'll be like a check. Make sure that you're here. Baseball, shot put, the exact same speed. Shot put's a lot heavier. Which one is going to have more momentum? So it seems to me like you guys are like kind of following each other in this. Now I want you to think about this. Let's put some numbers in here. Let's say the mass of the baseball is 1 kilogram. Let's just say that. Now let's say the mass of the shot put is 2 kilograms. It's actually a way bigger difference between those. Let's say that the velocity of the baseball is 1 meter per second. Let's say the velocity of the shot put is 1 meter per second. So if I were to times these, if I were to times mass times velocity, for the baseball it would be 1 times 1. That equals 1. For the shot put it would be 2 times 1. That equals 2. Which one has more momentum? The heavier shot put or the lighter baseball, if they're moving at the same speed? You can feel free to change your answer if you want.
Mr. Voltman.
Yeah.
So basically, if something or if an object has more mass with the same velocity, it goes over to has more mass.
So no. What I'm just saying, if an object has more mass than another object, same velocity, the more massive object will always have more momentum.
Okay.
Okay. So the relationship between mass and velocity, that's linear as well, as long as I'm sorry. This is a rough morning so far. So the relationship between momentum and mass, that's going to be linear as long as I keep velocity constant. All right. So if the mass gets bigger, the momentum will get bigger. It has to get bigger because I'm timesing these two numbers together. And when we talk more about changes in momentum, this will become obvious, right? Because if you think about sports, especially a lot of contact sports, people who are bigger, they have more momentum. So let's say that I have two people on ice skates in a hockey game. If they're going at roughly the same speed, but one of those people is a lot bigger, they're going to have a lot more momentum. And where you'll see the effects of that is where you have changes in momentum, like when that bigger person crashes into somebody when they do a check. You know, on the football field, same thing. If you have a really big person and they're running at roughly the same speed as everyone else on the field, they'll have more momentum. When they run into somebody else, there's going to be you'll notice the difference when they hit someone. That's something that we're going to talk about on Monday. It's called impulse. Impulse is change in momentum. So you guys, if I have the same object but I make it go faster, more momentum. If I have the same speed and I have a heavier object, more momentum. Lighter object, less momentum. So let's actually do a problem now. Okay? So here's my sample problem. I have a 4 kilogram shot put. That's the international size for the women's shot put. And it's thrown by Michelle Carter. She won the gold medal in the Olympics. Okay? Now she threw this shot put at a launch velocity. It left her hand at 13.5 meters per second. Just so you guys know, that's about 35 miles per hour. I want to know, what's the momentum of that shot put? Well, we know a few things in this problem. So we know the mass of the shot put. And the mass of the shot put's 4 kilograms. Says it right here. And then actually, just as a side note, if people are still writing, if I can make this bigger, you can see, if you've never seen a shot put before, that's a shot put right there. She's holding it against her cheek there, and she's getting ready to throw it. When you throw a shot put, you actually have to push it, which is why she's holding it like that, because it's so heavy. If you didn't push it, you would basically hurt all your muscles. Okay, now she's throwing this shot put, and it leaves her hand at 13.5 meters per second. So the velocity is 13.5 meters per second. And then it says, what is the momentum? So the momentum is our question mark. So right now we only have one equation for momentum, and its momentum is equal to mass times velocity. P momentum is equal to m times v. And we'll stick our variables in here. We have a mass of 4 kilograms. Just so you guys know, that's a little tiny bit under 9 pounds. And the velocity is 13.5 meters per second. You times those two things together, and it will give you the momentum. And you can check my mental math, but I get it to be 54 kilogram meter per second. So that would be her momentum. So are we all good there? You want to give me a thumbs up or type OK in the box? Okay. Now, here's the thing. This 54 kilogram meters per second, it's hard to know if that's big or small. We need something to compare it to, right? We need to kind of figure out for ourselves what these numbers really mean. So I'm going to do another example. Can I go to the next page? Yeah? Okay. So here's the next problem. So I have a baseball. Now baseballs are a lot smaller than shot puts. Now, they're still not really, really light, but they're a lot smaller. Now baseballs are 145 grams. We don't measure mass in grams. So anytime you have a problem, you guys, that's in grams, and some of your practice problems will have that, you're going to have to switch it to kilograms. So if you look at your conversion sheet, you have to divide it by 1,000. Or if you remember from chemistry, you move the decimal to the left 3 places. So the mass of a baseball is 0.145 kilograms. Now, just so you know, a baseball, it's a little less regulated than a shot put, so it could be anywhere between 142 and 147. I just picked a number in the middle. Okay, and then Lucas Giolito threw a no-hitter this year. It was pretty awesome. So his average fastball is 42 meters per second. So that's the velocity of that ball. Now, just so you guys know, that's 95 miles per hour. All right? And I want to know, what is the momentum of the ball? So I know the mass. I know the velocity. I'm looking for momentum. Remember, everybody, you write this on your test. You got 4 out of 10 points. And most people whose tests I've graded have been writing all that stuff down. Okay. Now, the only equation we have right now to solve for momentum is momentum equals mass times velocity. So let's plug in our numbers then. I have 0.145 kilograms times 42 meters per second. This one I can't quite do in my head, so I'm going to have to use a calculator. Okay, and if you were following along on your calculator, I got the answer to be 6.9 kilogram meters per second. You could tell me whether I'm right or not. Okay, awesome. So I have confirmation. So the baseball, you guys, that's traveling at 95 miles per hour, it has a momentum of 6.09 kilogram meters per second. That shot put, that was only traveling at roughly, traveling at roughly 32 miles per hour, it had a momentum of 54 kilograms meters per second. Okay, now that shot put had a lot more momentum than that baseball. Why does it have more momentum? Even though the speed is smaller, the mass of that shot put is way higher. So this speed is bigger, but the size of that baseball is a lot smaller, right? And as the mass goes down, momentum goes down. As velocity goes up, momentum goes up, but the mass went down a lot more than the velocity went up. So it's super impressive that Giolito can throw a 95 mile per hour fastball. I can't, right? Not sure if any of you can. But this is probably even more impressive, that she could throw a nearly 9-pound ball at over 30 miles per hour. That's a lot of momentum. It requires a lot of force to do that. We're going to talk more about the relationship between force and momentum on Monday. So not to you know not to demean what Giolito does, because that's really really hard. That's why he gets paid millions of dollars. But it's really really hard to be an Olympic shot putter. All right. So let's do one more problem before we go. So this is our last sample problem. And after these three problems, you guys, this should cover everything that's on the practice problem set. So sample problem number 3. I have a car, and that car is 1,000 kilograms. So I know the mass. I know the mass of the car, 1,000 kilograms. And then it says the car accelerates at 4 meters per second per second. So I know the acceleration of the car. So it gets 4 meters per second faster every second. We could either write it as 4 meters per second, or you could write it as 4 meters per second squared. All right. And then I know it's going to accelerate for 2.5 seconds. And then the question asks, what will its momentum be? What will its momentum be at the end of that 2.5 seconds? So let's look at our equation for momentum. All right. The only equation we have right now for momentum is mass times velocity. Now I know the mass. It's 1,000. But do I know the velocity? And the answer to that is no. I know the acceleration, but I don't know the velocity. Now there's one thing, this question was poorly written. Sorry about that. What we should have said that the car started from rest. Okay? So I'm going to move this stuff down. And if the car started from rest, what that means is that its starting speed was 0. So maybe it was at a red light, light turns green, and then you're accelerating for 2.5 seconds. So I know that its starting speed is 0. What I want to know is, what is its speed at the end of that 2.5 seconds? Because I need that to solve for momentum here, right? So this will be a 2-step problem. Remember, I told you cannot forget your old equations. We're going to be using them all year long. So if I want to know the ending speed, and I know the starting speed, the acceleration, and the time, if you look over your equation list, we have an equation that says the final velocity is the original velocity plus acceleration times time. So the velocity at the end of the 2.5 seconds is going to be equal to 0, because that was the starting speed. It was at my red light. Time plus the acceleration, which is 4. Times the time, which is 2.5. Okay. So 0 plus anything, that's the 0. And 4 times 2.5, you could check that on your calculator if you need to, but that will be 10 meters per second. So the velocity that we're going to use to solve for momentum, that's going to be 10. So now if I go back, now I can solve for momentum, because momentum is the mass, which is 1,000 kilograms. And v is the velocity, 10 meters per second. And if I punch that in my calculator, 1,000 times 10, you're going to get an answer of 10,000 kilogram meter per second. So there will be problems on your practice problem set, that are 2-step problems. You guys, you'll have to solve for, say, acceleration. I mean, you'll have to use acceleration to solve for velocity, and then you'll have to plug it back in here. There might be problems as well where you have to solve, like for the final velocity using the momentum equation, and then plug it back in to find acceleration. Okay, but there will be some two-step problems. There will be plenty of problems on your problem sets too that are just one-step problems, like these.